Swayam Prabha. Digital India. Educated India.
Hi friends, we will now start discussion on the third part of the module waste characterization under the course waste to energy conversion. In this part we will discuss on the characterization of waste water. As discussed earlier, waste water have different properties or characteristics. Those can be categorized into three categories, that is physical, chemical and biological properties. Now we will discuss how we can get the values of these different properties or the characteristics. Different physical properties of wastewater include temperature, total solids, suspended solids, then dissolved solid, color, taste, odor. This total suspended solids, that is TSS, and dissolved solid, that is total dissolved solids TDS, these may be of two types. One is fixed suspended solids and another is volatile suspended solids for TSS, and for TDS those are fixed dissolved solids and volatile dissolved solids. These volatile dissolved solids is more important on energy production point of view. Among different chemical characteristics, we will see the hardness, biological oxygen demand BOD, chemical oxygen demand COD, nutrients like say nitrogen and phosphorus present in wastewater, different salts and different ions, cations and anions, heavy metals, total organic carbon and dissolved oxygen. So, out of these properties, the biological oxygen demand, chemical oxygen demand and the total organic carbon are very important on energy production point of view, and heavy metals and dissolved oxygen, these are also play significant role because heavy metals influence the growth of the microorganisms and dissolved oxygen is also required for the bacterial degradation. If we think about the biological quality parameters of wastewater, then it may include the aquatic plants and animals present in it, and like say single cell to fish or trout, and pathogens, basically the microorganisms capable of infecting or transmitting disease to humans. So, these two are measured biological water quality parameter, but these are not so much important in terms of energy production. Now, we see some important parameters and we will discuss the analytical methods or other methods through which we can get the value of these parameters. So, here TSS, that is total suspended solids of any wastewater, is measured indirectly by measuring the turbidity. So, turbidity meter is available. Using turbidity meter we will measure indirectly the total suspended solids, and TDS, total dissolved solids, we can measure it through gravimetric method or conductivity meter. So, gravimetric analysis means we will apply heat. So, water will be vaporized. So, the residue will be on the container and we will get that weight difference and get the weight of the TDS present in the wastewater sample. Now, TDS may be a fixed TDS and volatile TDS. So, once we are heating the wastewater at 105 degree centigrade, so that all the water is vaporized and the residual part is remaining up to constant weight. So, that is your total TDS, and out of this total TDS, if we further apply heat say around 550 degree centigrade for certain times around 15 to 20 minutes, so then we will get some difference of this weight. because of the volatilizations of the TDS which are volatile in nature. So, that weight loss is volatiles due to the volatiles and the remaining is for fixed TDS. Alkalinity we can measure it by pH meter, and the color we can measure it by spectrophotometer. Then odor measurement test is done by its dilution, and threshold odor number is one parameter which has been derived, that is ml of sample plus ml of odor free water. So, we will be taking odor free water, and we will also be mixing this odor free water with the sample water, and we will test the odor of it, and we will be diluting this until we can get a barely perceptible odor. So, that is our threshold limit, and by definition TO is equal to ml of sample plus ml of odor free water divided by ml of sample. Now, inorganic substances like say cations and anions, those can be measured by different chemicals methods as well as analytical methods. So, spectrophotometer is used for this, and for the measurement of the concentration of heavy metals, atomic absorption spectroscopy and ICP-MS, inductively coupled plasma mass spectroscopy is used. When very low concentration is required, then we can go for ICP-MS, otherwise AS, atomic absorption spectroscopy is a suitable one. Another parameters which are more important when we think about the energy production from wastewater, those are DO, dissolved oxygen, BOD, biological oxygen demand, COD, chemical oxygen demand, and TOC, total organic carbon. So, we will be putting more emphasis on the measurement of these DO, BOD, COD, TOC, and also the trace metals. Now, what is DO? Dissolved oxygen. So, any wastewater sample will be having some dissolved oxygen, because air is diffused from air to the water through the surface of the water, and always certain amount of oxygen is present as dissolved oxygen in the wastewater. The value of this DO for surface water at normal conditions is around 9 to 10 ppm, but it varies depending upon the conditions. Now, our objective is to determine the concentration of dissolved oxygen. So, we have to develop some methodology, maybe in through some chemical methods or maybe using some instrument. So, the chemical methods which was first used for this determination of dissolved oxygen, that was Wrinkler's method, and in this method Mn2 plus containing salts is added in certain amount of water in excess amount, and potassium iodide is also added in alkaline medium. So, under these conditions Mn2 plus present in the solutions is converted to MnO2 in aqueous, and this MnO2 aqueous forms brown precipitate, and here 1 mole of oxygen reacts with 1 mole of Mn2 plus. Now, this MnO2 brown precipitate is further dissolved into solution by adding acid. So, when this acid is added to dissolve the MnO2 in the solution, then that MnO2 reacts with iodide ions in presence of H plus and forms iodine. Now, here 1 mole of iodine is produced from 1 mole of MnO2, and 1 mole of MnO2 is produced from 1 mole of oxygen. So, amount of iodine which is produced now in the solution is equivalent to the amount of oxygen in terms of moles present in the wastewater or any water sample. Now, we have to quantify the iodine present in the solution, and for this purpose it is titrated with sodium thiosulfate. So, sodium thiosulfate converts iodine to iodide and it is converted to tetrathionate. So, this when the iodine is present, if we use torch indicator we will get some blue coloration. So, when the iodine concentration is reduced and it is converted to iodine, at end point the color will change, it will be colorless. So, we will get the end point, and then from the end point calculation we will get the strength and volume of thiosulphate used, and correspondingly iodine reacted with this thiosulphate we can calculate by this reaction, and equivalent amount of oxygen is also present in the wastewater. So, this is the method for the determination of DO through Wrinkler's method. In this method there are some possibility of interferences, like say presence of nitrites, iron, ferrous salt plus 2 state, even suspended solids can interfere on the concentration of DO. So, some correction is required, that is we have to add some other chemicals like say some azide, permanganate and alum are used to remove the interference due to nitrite, ferrous iron and suspended solids. So, this is the procedure for the determination of DO through Wrinkler's method. Nowadays, with the advancement of the instrumentation, some instruments like DO meter is available to directly measure the concentration of DO, dissolved oxygen, in the water or wastewater sample. In this case, one DO sensor is used. In DO sensor, a specific electrolyte is used, that is made of KCl, specific strength of KCl, that is used in the electrode in the cell, and then in this cell we have two electrodes, one is anode and another is cathode. The anode is made of silver and cathode is made of gold, and this chamber is separated with the sample water or wastewater through gas permeable membrane. So, now oxygen which is dissolved in water sample, that will pass through this permeable membrane, and when KCl is used, so silver of anode is converted to Ag plus and forms AgCl and emits electron. So, this electron which is emitted here by the anode, that electron helps to react oxygen with H2O water molecules to form OH minus in the cathodic part. So, we will get one current, and that current flow is directly proportional to oxygen concentration which is diffused, or oxygen which is diffused through the membrane, or in short the concentration of dissolved oxygen in the water. So, directly we can get the dissolved concentration of the wastewater using this DO probe. Next important property is BOD, that is biological oxygen demand, and we have discussed earlier that BOD is nothing but the amount of oxygen required for a wastewater sample for the degradation of organic compounds present in it by the microbials or microorganisms present in it. So, for this purpose obviously we need to determine the dissolved oxygen or DO value at initial stage and DO value after certain stage. So, differentiating the value of DO will be give us the oxygen reduced due to the oxidations of the organic compounds, that means that will be proportional to the organic compounds present in it. Now, how to do so? For doing so, we have to take 2 BOD bottles, and 2 BOD bottles, say around 300 ml BOD bottles, we will put sample water plus dilution water and make 300 ml volume, 2 BOD bottles, and DO content of one bottle will be tested immediately, and DO or dissolved oxygen content of another bottle will be tested after 5 days incubations, and incubations will be done at 20° centigrade in a dark place, in total darkness. Means this dilution water is required to reduce the concentration of the organics present in the wastewater if it is in higher extent, and the ratio of wastewater and dilution water will vary depending upon the initial concentrations of the wastewater, that is solid organic solid concentration or BOD value in the wastewater. This dilution water contains calcium carbonate, magnesium sulphate, ferric chloride and phosphate vapor. Two blank tests are also done. In these two blank tests, another 300 ml BOD bottles are used and filled with dilution water only, no wastewater. This is done because to remove the errors, because the dilution water may have some organics theoretically and it may have consume some oxygen. So, to reduce that the blank tests are done. So, out of these two blank tests, the DO of one test is measured on t equal to 0 or the same day, and another is for t equal to 5 on a 5 days. This 5 days incubation at 20 degree centigrade can be replaced by incubation for 3 days at 27 degree centigrade. So, BOD in this case we can get 3 day BOD or BOD 3, and the first case we get BOD 5 or 5 day BOD, but it has been proved that under these two conditions almost BOD 3 and BOD 5 values become similar. One thing is done, if some specific organics are present in wastewater, then specific microorganisms may be added. So, some seeding of microorganisms is also necessary in some cases for the determination of BOD 5 or BOD 3. And when we are adding the seeds, the formula for calculation BOD 5 changes slightly. Here we see how it changes. So, for unseeded samples, the BOD 5 can be calculated as BOD 5 is equal to D, that is dilution factor, BOD 5 is equal to D dilution factor into DO dissolved oxygen at t equal to 0 date minus dissolved oxygen t equal to 5 date for sample minus DO t equal to 0 minus DO t equal to 5 for blank is equal to D is the dilution factor. So, for example say we have taken 30 ml of wastewater, 30 ml of wastewater plus 270 ml of dilution water. So, it will give us 300 volume, 300 ml. Now, out of this 30 ml we had, now the volume is 300. So, dilution factor, dilution is equal to 300 by 30, that is equal to 10 times. So, that way we calculate the D. Now, D into DO at t equal to 0 and at t equal to 5 for sample minus DO for t equal to 0 and DO for t equal to 5 for blank. Now, this value DO for blank sample at t equal to 0 and t equal to 5 is not much, it is normally less than 0.2 mg per liter. So, in many cases this is ignored and directly BOD 5 is calculated by this formula. But when seeding is done, means microbes are added externally, in that case the formula changes to some extent. This is similar, only here we have to multiply by some F, some factor, we have to multiply it by some F. So, this F is equal to what? F is the ratio of seed volume in dilution solution to seed volume in BOD test on seed. Normally it is around 1. So, in this case say 270, say we can consider that the seed volume in dilution water, say out of 300 ml we may have 5 ml seeds. So, 270 ml we may have 5, or we can say here we are considering 5 ml we are adding. So, it is in 300 ml for dilution, but say for the real sample we are adding 270 ml dilution water plus 30 ml of wastewater. So, here we are having seed is equal to 5 into 270 divided by 300, which is present in 300 ml of this. So, that is in that way, this way we can calculate the F value, the ratio of it, but F value is normally near to 1. That is why directly we can put this formula, putting F, particularly when dilution is very high. Now, we will discuss on COD measurement. So, COD is chemical oxygen demand. So, for the measurement of COD, we have to oxidize the organic compounds present in wastewater by chemical means, and potassium dichromate is normally used for the oxidation of the organic compounds present in the wastewater, so that potassium dicarbonate is reduced to chromium 3 as per the reactions as shown here. So, this is organic compound is converted to chromium 3 plus and CO2 and H2O and NH4 plus. Now, if we take two samples, one is wastewater and another is blank distilled water. So, distilled water will have no organic compounds, but the wastewater will be having. So, when we will be using dicarbonate in acid media and we will allow the two samples for digestions, that is 2 hour heating under total reflux conditions. So, some of the dicarbonate will be reduced in the real water sample, but in blank that will not be reduced. Then we will be following some titration method to know the remaining concentration of the potassium dichromate, and that is done by using ferrous ammonium sulphate, and there will be some endpoint, and from the endpoint we will be calculating the amount of ferrous ammonium sulphate consumed, and ferrous ammonium sulphate consumed will be proportional to remaining potassium dichromate. So, that way we can calculate for the blank total dichromate, and for the real wastewater sample the remaining dichromate. So, by differentiating these two we can get the dichromate which is consumed by the organic compounds for their oxidation, and we can get the value of COD. Here the formula which is used to calculate COD is equal to COD is equal to 8000 into B minus S into N divided by volume of sample volume. What is B? B is the volume of S used in blank sample, and S is the volume of ferrous ammonium sulphate used in case of real sample. So, B is more than S, and n is the normality of the phase. So, if we put all those things in ml, then this COD value will be in mg per liter. In this case also, the presence of chloride and nitrite can interfere COD test, since they are also oxidized and contribute some inorganic COD. Chlorine and nitrite. So, nitrite interference can be eliminated by using sulfamic acid, and to reduce the chloride interference, mercurous sulphate is used. Now, with the development of the instrumentation, again in this case also using some colorimetric method, directly COD value can be calculated or determined. What happens in this case? The chromium 3 plus, which is produced during oxidation process, that is proportional to the organic compound present or oxidized during this reaction. So, during this process, the conversion of dichromate to chromate, the change of the solution takes place, and for blank and for real sample different color we get. And now for Cr3 plus, the color intensity is proportional to the concentration of Cr3 plus. So, if we use a light of certain absorbance which is applicable for Cr3 plus, then the absorbance value will give us the indication of the oxygen used or the organic compound present. And there are some calculations and some softwares are available in the machines that convert these absorbance to COD and directly gives the COD value. For blank test, this is put 0, and for real sample this is determined directly. Next we will see the TOC, total organic carbon measurement. So, total organic carbon present in the solution, if we apply heat, then those will be converted to. So, if the temperature is less, then inorganic C is converted to CO2, but if temperature is high, then organic carbon is converted to CO2. Then that CO2, after condensing the gas, means the H2O will be removed, and then only pure CO2 will be going through the off gas, and that CO2 concentration can be used by using non-dispersive infrared analyzer, or that CO2 can be converted to methane, and that methane concentration can be measured, and indirectly TOC can be determined. So, that way when we will be using only 150 degree centigrade temperature, then we will get inorganic TOC, and when we will be using 900 degree centigrade, we will be getting both. By difference we will get the organic TOC. So, these are the very important parameters for wastewater on energy point of view, that is DO, BOD, COD and TOC. So, we have discussed and we have come to know how we can get the values of these characteristics of wastewater. So, thank you very much.